Bismillahirrahmanirrahim. In this tutorial, we will solve one numerical on the basis of concept of modulation from chapter 2. We will explore an interesting aspect of communication system that how modulation affect antenna size. Let's start with a simple example. Imagine a communication system transmitting a signal at frequency of 5 kilohertz. In such a system, we typically need a half wave antenna size. This question revolves around the relationship between the signal frequency and required antenna size. Let's break it here. The data is given about speed of light 3 into 10 power 8 meter per second. Frequency F1, we have a two frequency and we want to compare the size of antenna for these two frequencies. So first frequency is 5 kilohertz and second frequency is 100 megahertz. And because our question depends all on the basis of hertz, so we convert 5 kilohertz into 5000 hertz and 100 megahertz into 100,000 megahertz here. So now we use the equation that lambda is equal to c over f, where c is the speed of light and f is the frequency and lambda is the wavelength. And similarly, the antenna size, the length of antenna required is half of the wavelength, so which is equal to the capital L is equal to lambda 2, where lambda is calculated from the above equation. So now we have calculate wavelength for f1, which is 5 kilohertz. And as in previously slide, we see that lambda is equal to c over f1. C is equal to 3 into 10 power 8 meter per second. And frequency 1 is 5 kilohertz. So we will write here 5 kilohertz. And after simplification, our lambda 1 is equal to 60,000 meters. As we have already discussed that antenna size is required the half of the wavelength, which is L1 is equal to 60,000 divided by 2, which is 30,000 meters. Now, from this simple solution, we realize that 5 kilohertz frequency is really not possible that we provide 30,000 meters, a 30 kilometer antenna for the communication. Now, let's see when we increase the frequency, then what will happen the uh, antenna size here. Here you will see that our lambda 2 is equal to 500 megahertz and lambda 2 is calculated, our frequency f2 is 100 megahertz. Lambda 2 is equal to c over f2 and we calculate the lambda 2 is equal to 3 meters. So antenna size, we calculate length of antenna is lambda 2 by 2. So here we find 1.5 meter, which is highly practical. So we realize that if we just shift the frequency from 5 kilohertz to 100 megahertz, then our antenna size become highly reasonable. And this is the purpose of the modulation. We realize that if our message is 5 kilohertz, then with the help of a carrier wave, with the help of modulation, we can make a modulated signal 100 megahertz, and our antenna receiver side antenna is just 1.5 meter, which is highly practical as compared to lambda, which is 5 frequency 1.5 megahertz, 5 kilohertz. So we realize that if we increase the frequency of the modulated signal, then we will get reasonable size of the antenna. Thank you.